Welcome everyone to BTT 151 Fundamentals of Electricity. I'd like to go over your Unit 2 homework solutions. And what I've done, the Ohm's law calculations for the bulk of the problems. I've solved problems 6 through 14 with the numerical responses on the board here. The other remaining questions, I will just give you the correct answers to as you work through them. All right, so let's begin. Question 1. Metric units of measure are used in the electrical field just as they are used in most scientific fields. That's true. Question 2. What is a coulomb? A coulomb, remember, is the quantity of charge or the quantity of electrons. Remember, a very large number, 6.25 times 10 to the 18th electrons are contained within 1 coulomb of charge. Question number 3. What is an amp? An amp is defined as that unit of charge, 1 coulomb per second. Question 4. What is an ohm? Remember, an ohm is the unit of resistance or opposition to current flow. Question number 5. What is a watt? The watt, remember, is a definition of electrical power in a DC electrical system. And now some of the Ohm's law calculations. Question 6. An electric heating element has a resistance of 16 ohms and is connected to a voltage of 120 volts. How much current will flow in this circuit? I always like to write down all the information that's given. So resistance is 16 ohms, voltage is 120 volts. We're solving for the current. So from Ohm's law, I is equal to V divided by R. Plug the numbers in, 120 divided by 16. The current is 7.5 amperes. Question number 7. How many watts of heat are being produced by a heating element that has a resistance of 16 ohms connected to a voltage source of 120 volts? Resistance of 16, voltage of 120. Power is equal to the voltage squared divided by resistance. So plug the numbers in, 120 squared divided by 16 gives you a power of 900 watts. Question 8. A 240 volt circuit has a current flow of 20 amps. How much resistance is connected to the circuit? Voltage of 240, current of 20 amps. Ohm's law, again, resistance R is equal to V divided by I. Plug in the numbers. 240 divided by 20 gives us a resistance of 12 ohms. Question 9. An electric motor has an apparent resistance of 15 ohms. If 8 amps of current are flowing through the motor, what's the connected voltage? 15 ohms of resistance, current of 8 amps. Solve for the voltage. V is equal to I times R. Plug the numbers in, 8 times 15. Voltage is 120 volts. Question number 10. 240 volt air conditioning compressor has an apparent resistance of 8 ohms. How much current will flow in the circuit? Voltage of 240, resistance of 8 ohms. Solve for the current. I is equal to V divided by R. 240 divided by 8 leaves us with a current of 30 amperes. Question 11. How much power is being used by a compressor if it is connected to a 240 volt supply and has an apparent resistance of 8 ohms? 240 volts, 8 ohm resistance. Solve for the power. Power is equal to V squared divided by R. Plug the numbers in. 240 volts squared divided by 8 will give us a power of 7,200 watts. Should also point out, using engineering or scientific notation, 7,200 watts can also be specified as 7.2 kW, and it's very commonly done. Question 12. A 5 kW electric heating unit is connected to a 240 volt line. What's the current flow in the circuit? Most important thing to keep in mind, 5 kW, always have to get units in base. In other words, 5 kW is 5,000 watts, so we have to convert kW back into base units. Power is 5,000, voltage is 240. Solve for the current. Current is equal to power divided by voltage, so 5,000 divided by 240 gives us a current of 20.83 amps. Question 13. 5 kW electric heating unit is connected to a 120 volt line. How much current would need to flow in this circuit? Power is 5 kW, voltage is 120. Again, solving for current. Power divided by voltage, 5,000 divided by 120 is 41.67 amps. Question 14. A 1 watt 350 ohm resistor is connected to a 24 volt supply. What is the actual power being dissipated by this resistor? Resistance is 350 ohms, voltage is 24 volts, so to calculate the actual power capacity, power dissipated in the circuit, voltage squared divided by R, 24 squared divided by 350, or 1.65 watts. So what this problem means practically, they specified a 1 watt 350 ohm resistor, but our analysis shows that the resistor is going to dissipate 1.6 watts of power, so the resistor is undersized. All right, the remaining questions I will just give you the correct answer to using the same techniques you've seen with Ohm's law. Question 15. A 1500 watt heating element has a resistance of 38.4 ohms. How much current is flowing through the heating element? So the correct answer for current would be 6.25 amps. Question 16. A 1500 watt heating element has a resistance of 38.4 ohms. How much voltage is applied to the heating element? 240 volts. Question 17. A 100 watt lamp is connected to a 120 volt circuit. How much current will flow through the lamp? 833 milliamps. Question 18. A 15 watt soldering iron is connected to a 120 volt circuit. What's the resistance of the iron? 960 ohms. Question 19. A 300 watt heating element is connected to a 277 volt line. How much current will flow in this circuit? 1.083 amps. And then last question, question 20. A 1.5 k ohm resistor has a current of 8 milliamps flowing through it. How much voltage is applied to the resistor? 12 volts. Okay, thank you.